You water it, you give it a prime spot, you watch it push out healthy, vibrant leaves month after month, and yet zero flowers. It is incredibly frustrating. We tend to assume that if a plant is green and growing, it is naturally progressing toward a bloom. We equate basic survival with a readiness to flower. But plants do not operate on aesthetics. A flower is not a decorative choice. It is a specialized biological mechanism built strictly for reproduction. Every day, your plant is running a quiet internal calculation. It assesses the light, checks the soil and the temperature, deciding whether its current environment justifies the massive risk of reproduction, or if it should conserve its resources just to stay alive. When a healthy plant refuses to bloom, it isn't broken. It has simply analyzed its surroundings and logically decided that the environment is built for survival, not reproduction. This chart breaks down the plant's internal economy. Growing a leaf is biologically cheap. It requires minimal resources and almost immediately starts paying for itself by gathering light. Flowers are highly expensive, draining energy. If a plant gets 4 hours of sun instead of 8, it faces an energy deficit. It restricts spending entirely to cheap leaves, refusing to bloom until sunlight income crosses the specific threshold required for reproduction. But even with perfect sunlight, caretakers often accidentally sabotage the process with the very fertilizer they apply. General-purpose fertilizers are heavily weighted with nitrogen. Nitrogen is the chemical fuel for leafy, green growth. When you pump a plant full of it, you send a dominant chemical signal commanding the plant to prioritize foliage, effectively suppressing its reproductive systems. To authorize a bloom, the plant needs a different chemical signal, phosphorus. While nitrogen builds the leaves, phosphorus triggers the specific hormonal shift required to produce buds. Put a plant in partial shade and feed it heavy nitrogen, and you build a biologically trapped organism, an artificially lush plant permanently locked in a vegetative state. There is also a strange paradox in botany. A perfect, highly comfortable environment actively disincentivizes a plant from reproducing. In nature, plants rely on environmental shifts, a sudden drop in temperature or the onset of a dry season, as a warning. These changes signal that the current ideal conditions are ending, creating a sudden biological urgency to reproduce before it's too late. This graph illustrates how slight stress acts as a catalyst. By intentionally backing off the watering schedule or letting the roots become slightly restricted, you simulate that natural urgency. The plant senses its own mortality and immediately triggers a reproductive response. Beyond stress, there is a mechanical trap, timing. Many species, especially old wood bloomers, are deeply sensitive to when they are pruned. If a plant blooms in early spring, its buds actually formed months prior, hidden in the branches. Cutting that plant back in late fall means you are physically severing its reproductive capability before the buds even become visible. And finally, age plays a factor. A young plant simply lacks the root infrastructure to support the energy drain of a bloom. It must build its foundation before it can biologically handle the weight of reproduction. Forcing a bloom is an equation. It requires aligning the chemical inputs, introducing precise biological urgency, and ensuring mechanical timing is correct. Your plant is a logical organism. When it refuses to flower, it is executing a response to the exact environmental parameters it currently experiences. Light budgets, phosphorus levels, mild stress, and pruning cycles function as a readable environmental language. You transition from pouring water for survival to architecting an environment designed to command a biological life cycle. And when that first bud finally opens after weeks of observation, the experience is different. You know exactly which signals you adjusted. Because once you understand the strict rules governing survival and reproduction, the frustrating mystery of a green, flowerless plant becomes a science you can master.